Today we are going towards trigonometry, IGCSE Mathematics over there. According to the word, the meaning trigno means triangle, triangle, and metry means to measure it, to measure. And if we talk about triangle, it means it has three main vertices, and we join these vertices, then we can say a closed shape is formed, which is called triangle. It has basically six parameters, three sides, and three angles over there. And if I name these vertices like A, B, and C, the opposite side of angle A is named as small a over there. Opposite side of this B is being given length of this side AC as B, and opposite side of this C is also being shown by small letter C over there. First of all, in while going towards a trigonometry, the basic concept behind it is going to be taken for a right angled triangle as a basic triangle for the measurement over there. We say here one angle is 90-degree, and the side which is opposite to 90-degree is named as hypotenuse. And if I am taking and describing according to this angle A over there, then I am saying that adjacent side to angle A is named as base or adjacent. And if I am taking opposite side of angle A, this is called opposite or perpendicular, like that. If we want to calculate its angle or sides over there, for if the two sides are given and I want to calculate the third side, then I will use Pythagoras theorem over there, which states that Pythagoras theorem, which states that hypotenuse square is equal to base square plus perpendicular square. Let's suppose here I am saying opposite to vertex B, hypotenuse is B, and base is opposite and having C side, and on the other end this opposite is having the length A over there. Let's suppose I say there is a triangle with the length of hypotenuse given with 5 centimeter, and opposite is given with in the form of A as 4 centimeter, and I ask to you go for calculation of the side B over there, which is in the form of and go to calculate for the side C over there, which is being taken as base. Then you will use the formula and you will place these values over at the respective positions over there. B is our hypotenuse as shown in figure. Then I am saying here that always remember, if these letters are not mentioned over there, opposite side to 90-degree is always hypotenuse, which is coming on this side. You are writing it 5 square is equal to C. You want to calculate, then put it C square plus perpendicular is A, which is given as 4 centimeter, then place it 4 at square. And you want to make subject for this C square, then you will say C square will equal to 5 square minus 4 square over there. And it can be 25 minus 16, which will equal to 9 as C square. So C will equal to square root of 9 over there, and it will equal to 3 centimeter. If you are provided with, let's suppose I say, on the in the other example that you are provided with two B you want to calculate over there, and A and C are given to you. For example, I say A is given as 6 centimeter and C is given as 8 centimeter. I ask to you go and calculate B over there as hypotenuse. Then by putting the values according to this rule, you will simply place them according to the formula. Like you want to calculate B square in the form of hypotenuse, then you are putting the other two values in the form of squares. Then it is 36 plus 64 and uh, let's go to calculate this now. It is 36 plus 64 is 100 is b square. So I'm saying b square is equal to 100. Take the square root on both sides. You will get as b equal to 10 centimeter. And on the other end, if I ask to you go and calculate A over there, which is perpendicular, the same pattern as you have done with the base will happen over there for the calculation of unknown sides over there. Mostly the practical questions are given according to Pythagoras theorem, like there is a wall with which we can say stairs are leaning over there, and the height and the base is given. What is the length of the ladder mostly is being asked over there in as an application. Sometimes it is asked that there is a flag which is mounted on a pole over there, and sun is shining on its this side over there, and its shadow is being formed over there, and the end of the shadow from the base of the wall is given, and he is saying that flag is x centimeter away and it is y centimeter away. What is the height of the pole over there? So Pythagoras theorem is being implemented in different cases of triangular shape in the form of right angled triangle formation over there being taken into account. If I go more in detail of right angle triangle, because till here I have only talked with the three parameters of the sides. I didn't talk about the other three parameters which are related to angles. Let's move towards the angles now. For example, here I am saying that it is a right angled triangle in which I am saying that this is angle B, which is 90 degree. This is angle A. This is angle C over there. And what I am saying, I'm talking according to angle A over there. And then it is my base. It is my perpendicular. This is my hypotenuse. And if we observe the calculator, there are some letters like sin, cos, and tan is written on our calculator. If I say I'm taking sin A, then it means that he is talking according to, it was also named as opposite, it was adjacent also. So I'm writing according to opposite and adjacent for that ratio. When I am talking about opposite, then I am saying for sine A, according to this angle A, my perpendicular is O and hypotenuse is still there. Then O over hypotenuse, opposite over hypotenuse will give me sine of A. Cos of A will be given as A over H.
Sir, I'm not understanding the formula.
Formula is sine A and sine cos A and tan A. These
Yeah.
are the ratios of the sides over there. If I'm taking sine
Okay.
A, angle of sine A, if I show you on calculator over there, for example, here I show you sine of some side. Let's suppose I am taking here as my base 4, as my perpendicular 3, hypotenuse as 5. Then what will happen? How I can calculate what is the angle over here? The method is, if this angle you want to calculate angle A, you will take opposite side over hypotenuse side. For example, you are taking here 3 over 5 like that. So sine A is equal to 3 by 5. Cos A will be equal to 4 by 5. And tan A will equal to opposite over adjacent, opposite over adjacent, which can be written as 3 by 4.
3/4.
And if I am taking, if I'm tilting the triangle like this, like it has formed like now, like this is perpendicular and I have tilted it now in this format, like this. And now I'm saying the right angled triangle is here and I have tilted it now. My C has reached here, my A has reached here and base is still there. Okay. Now I'm saying, tell me, according to this angle C, opposite side of C is now become the opposite, adjacent here, and hypotenuse here. In this case, if I want to calculate angle C, my adjacent before it, base was 4, now 4 is shifted here, and 3 is shifted here. Now I'm saying sine of C, cos of C, and tan of C will be calculated as opposite over hypotenuse, opposite over hypotenuse. Remember that here one word, that sine will be opposite to that angle which you are taking for calculation, or which is given and you want to calculate unknown side over there. Then if angle is given, we will twist it, and opposite side over hypotenuse will be calculated by sine. After that, cos will always be
Opposite
according
over
to
hypotenuse.
what?
Opposite over hypotenuse, right?
Yeah, and cos will be adjacent over hypotenuse and tan will be opposite over adjacent. And for this one, sine C will be 4 by 3, 4 by 3. After that, cos will be, no, I have written wrong over there. It will not be 4 by 3. It will be 4 by 5.
3, 4,
Yes, 4 by 5. And
5.
cos C will be 3 by 5 because hypotenuse is 5. And opposite over adjacent 4 by 3 for 10. How this it will be calculated? Like angle C will be taken from the calculator over there. I will say angle C is equal to sine inverse 4 by 5. Let's look how calculator is going to calculate it. First of all, press shift with sine. Look, it is writing now sine inverse. Introduce the fraction over there and write 4 over 5. You will observe here, you will get the value 53.13. I'm rounding it off and writing it 53 degree only. After that, cos of C means if I need the angle C from the cos over there, then cos inverse 3 by 5. Let's look, is it giving the exact value same over there or it is changing over there? Shift cos, it is cos inverse, fraction is introduced over there, then it means 3 by 5. 3 over 5, and now getting it in the form of the value 53.13. So in any ratio which I am taking here is giving me the same answer. Let's check for tan also. Angle C is equal to tan inverse 4 by 3. Let's check for this one also, that it is tan inverse 4 by 3. Shift tan inverse Fraction introduced, 4 over 3, giving us the answer equals to 53.13. So for all of these cases, the value is not changing. Only the length sides are twisting according to the rules. For example, for memorizing which will be going to work, it will be taken, I will say here, so ka toa. What it means? For sine, S for sine, theta will equal to opposite over hypotenuse, OH, opposite over hypotenuse. Kah means cos. Theta is being used for angle over there. It means it is adjacent over hypotenuse. And for tan, T for tan, theta is equal to opposite over adjacent should be taken into account for trigonometric ratios. These are named as trigonometric trigonometric ratios. I will also add here a little bit more information related to this, their values, which you should try to memorize a little bit, like sine theta, cos theta, and tan theta. I will say here 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. I'm talking about sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 over under root 2, sine 60 is under root 3 by 2, and sine 90 is 1. Okay, and cos 0 is 1. I'm just twisting the values from 90 to 0. Then under root 3 by 2 is cos 30. For 45, it's staying as it is. For 60, it is 1 by 2. And cos 90 is 0. Tan is 0 by 1, means tan is taken by the ratio of sine and cos also. We can say tan theta is equal to sine theta over cos theta. We can also say like this, that tan theta is a ratio of sine theta over cos theta, like that. So tan 0 is 0. Tan 30 is 1 over under root 3, and in this it is having the value 1, it is having the value under root 3, and the last value for 1090 is taken as infinity over there. After that, if I am talking about trigonometry, then I will say here for calculation of angles, for example, I am giving you here an example to be taken into account, where I am saying this is a right angled triangle in which you are provided with 90 angle, and you are asked to calculate with A, B, and C, and the two sides. Let's suppose hypotenuse is given as 15 and perpendicular is given as let's suppose 9. You are being asked to calculate the length of C over there, and also find angle A and angle C over there. How you will go over there? Then we will have to use or manipulate. First of all, for calculating the side C, we know that Pythagoras theorem is going to help us, and we will say 15 square is equal to C square plus 9 square, and then you are subtracting it, and C square is equal to 15 square minus 9 square. It is going towards 225 minus 81 is C square. Taking the square root over there, let's check the value is square root of uh, square root of 225 minus 81 equals to, it is 12. So C is equal to 12 there. So I will say here, I have calculated the one side which he is asking me to solve over there. I am done. Now he said to me, calculate the angle A and angle C also. So angle C, if I want to calculate, then the sides which I have, now C is 12 for me already given. I can use any trigonometric ratio. I can use sine for A. I can use cos for A. I can use tan for A. It means if I want to calculate sine according to sine of A, then I'm using only this one. For other two, just I have told you, you can use, if you remember the trigonometric ratios exactly, you can use any one of them. So sine A is being taken, and I am taking here angle A is present at this vertex. So sine is opposite over hypotenuse. So I will write it 9 over 15, and I want to calculate angle A over there, which will be taken as sine inverse 9 over 15. Remember that if you get like 15 over 9, it will not be possible for getting the solution. I will show you here how I am saying this. For example, I'm just taking an example over here, like shift sine inverse, and now I am giving the fraction as 15 over 9. Just look, it will give me syntax error. It will give me like this, math error is present over there. Remember that when you are taking sine or cos, even though if I go with the cos also, if I go with cos, like I'm going with shift cos inverse, and I'm taking 15 over 9, like numerator is greater, 15 divided by 9, bracket close, still he is getting, it is math error. So remember that if you are solving the question and you are getting the fraction numerator as a greater number, it will not be possible to calculate that. You are going to do any mistake in the question. So it is not happening with calculation of that angle. Always try that numerator is smaller and denominator is greater over there. Okay, let's check what is the answer for our question right now. Shift sine inverse fraction introduced 9 over 15 is being taken, and let's check what the value is. Value is 36.87. I can write it 37 degree. And I also want to calculate my other angle, angle C over there. So angle C can also be calculated according to trigonometric ratios, but I know that the angle sum inside a triangle is 180 degree, and other two angles in the form of 90 and 37 already calculated. If I subtract these two angles from 180, I can easily get my angle C over there. 180 minus 90 minus 37, I will get 180 minus 90 minus 37. I will get my value as, oh, I have written not right. I have written, wait a second. 180 minus 90 minus 37 equals to 53. So my angle C will be 53 degree. We have tried to talk according to their trigonometric ratios, which are going to be implemented in our questions. Later on, I also go not right towards the right angled triangle. Now I am going towards normal triangle. Let's suppose I am taking a triangle over here where I don't have any type of angle 90 over there. I'm saying it is side A, it is side B, angle vertex B, it is vertex C over there. And in that case, I am saying this is my angle C, this is my angle B, this is my angle A. Now, if I'm not having any angle 90-degree, then I will use law of sines. What is meant by law of sines over there? Like A is having small a opposite side, C is having small c, and B is having small b as opposite side length of that angle. Then I will use a relation law over there. A over sine of A is equal to B over sine of B is equal to C over sine of C. What does it mean? How it holds over there? And what is this relation of the sides and angles? Because remember that you will be provided by three parameters, means two angles, one side, one angle, two sides, and remaining two angles and one side are remaining other three parameters. You will have to calculate them by using law of sines. And for example, you are provided in this case only with the three sides and you want to calculate the angle. And then we can say we can use the law of cosines. Law of cosines, for example, I say to you that a square is equal to b square plus c square minus 2bc cos a. Remember that if you are having side A here, you will have angle A there. Remaining two other sides are being taking square, being added and being multiplied by doubling and subtracting them. You are getting the answer in the form of A square is equal to B square plus C square minus 2BC cos A case. After that, if I take B square here, one thing is clear, cos B is here. After that, two other sides are pending, a square plus c square minus 2ac over there. If I take the side c square here, then cos c is here, cos c is here, and other two sides like b and a, 2ab is here, and a square plus b square is present there. Let's suppose I give you the first case in which I say two sides are given and angle between them is also given. Let's suppose I am taking here a triangle. And here I am saying A, B, and C. Small a, small b, small b and small a are given with three parameters. What are these three parameters? These three parameters are two sides like A and C is given. A is given like in the form of 5 centimeter. C is given in the form of 7 centimeter. And the angle between these two sides is also given in the form of, let's suppose, 30-degree. And I asked to you calculate B and also the other two angles over there. What will you do? So we can say here, let's suppose we are having A and C and we need B. B square is equal to A square plus C square minus 2AC cos of angle B, because B is already present as a side over here. How you will go? B square will equal to 5 square plus 7 square minus 2 into 5 into 7 into cos angle B is 30-degree given and I need to calculate this B over there. Then it is cos 30-degree present over there. Just take the square root on both sides and calculate the angle over, calculate the side B over there. Square and square root cancelled and B is equal to, let's go towards calculator and place all of the values exactly into the calculator, how he is behaving over there. Taking the square root, 5 square plus 7 square minus 2 into uh, 5 7 and cos 30. 5 into 7 into cos, no need of bracket now because cos will have its multiplication already as a hidden factor. Cos 30 degree, close the bracket, get the answer. It is 3.65. It means 3.7. So your B is 3.7. If I make a big triangle for you so that you can understand over there that you have calculated what? This was your A, this was your B, this was your C. You are having small a as 5, you are having C as 7, and you have angle 30-degree over there, and opposite side small b is coming as 3.7 over there. Now, if I say that right now you have four parameters now, three sides and one angle. I want to calculate angle A and angle C, and it is not a right angled triangle that directly I can use here sine, cos or tan over them. Then I will use this law of sines over there. The side which I have will have its sine of angle as denominator, and I will use that relation to calculate my angle over there. For example, I want to calculate angle A. Then angle A and A equal to 5. So 5 over sine of angle A will equal to 3.7 as a length over sine 30 degree. Remember that you don't have angle C. So never take both angles unknown in the form of variable like sine A and sine C, and you are taking 7 above. That is not able to calculate because two variables will be in that equation. So take the ratio or formula equation in this style. One is having unknown variable like an angle over there, one is having both known values over there. Then you can calculate sine A. I am taking in the place of 3.7. So 5 multiplies sine 30 over 3.7 will be equal to this, and angle A will equal to sine inverse 5 multiplies sine 30 over 3.7 there. Let's calculate and what the value we are getting over there. Like shift sine inverse is being obtained over there. No, shift is not active. Shift sine inverse fraction introduced. So it is 5 multiplied 730 multiply sine 30 degree. 30 degree is going to close, and in the denominator it is 3.7 and bracket close there. So the angle value is 42.5. 42.5. This is your angle A. Now you have the five parameters and your angle A is 42.5, and the third angle you know how to calculate. Just subtract these two angles from 180. So angle C will equal to 180 minus 42.5 minus 30 degree. Let's check what it is the value he is giving over here. The value is 180 minus 42.5 minus 30 is equal to, this is equal to 107.5. So angle C is equal to 107.5. This was a introduction related to trigonometry in which I tried to use sine, cos and tan and Pythagoras for right angled Pythagoras triangle, Pythagoras theorem for right angled triangle, right triangle. over there. And for normal triangle, like in the form of scalene triangle or isosceles or equilateral like that, for those triangles, I try to use law of sines and law of cosines over there. And in the next class, which will happen on Sunday, we will try to do these practices. I will share the link of this lecture in the form of YouTube video. You will have to watch and make your notes of every formula with the example. Try to take the random values, try to solve them. Just remember during using the calculator over there that in while taking sine or cos in the form of inverse function, you should never take your numerator greater than denominator over there. It should never happen. No happen. And for tan, it is possible. Tan is possible to get the greater value above and smaller value down over there. Right now, I will have to close here because I have the next class. And in the next class, I will try to compensate this time. And thank you so much for today, beta. Maria, are you there? Hello.
Yes, I'm here. I'm here. I'm here.
Okay, my son. Okay, you will have to revise this chapter, and I will share you with you the YouTube link. You will have tomorrow one day, and try to manage at least 1 hour for